All right, so section 1.2 dealt with describing numerical distributions. However, we didn't describe numerical distributions with a lot of detail. We kind of just, so whenever we would cuss, we would say things like the center is about 15 and the spread is, the data values span from 10 to 20 or something like that, right? And even outliers, like I think this is an outlier. In this section, we're going to learn more specific measures of center spread and how to classify outliers. Shape we've actually covered. We've covered that as much as we're going to cover that. So let's talk about some different measures of center. You guys should probably know these. We have means, medians, and modes, mean or average. Sample mean is calculated by taking sample mean is x bar, that's the symbol, and it's taking the sum of the data points divided by how many data points you have. And the population mean is called mu, and it is calculated in the same way. You sum up the values and you divide by the big N, which is the population size. So, you might say, well, of course, these are the same formulas. But you're going to see with a couple things down the road here that our sample formula is not always the same as our population formula, okay? Interpretation, the average height of a sample of JCS students is 66.9 inches. So if you wanted to interpret the average, you just say it's the average. Median. Median is the middle number. To calculate the median, you put the data in order, and you just kind of count towards the middle. If you have odd data, then the middle number is your median. If you have even data, the middle is going to kind of be between two numbers, and you just take the numerical average between them. The interpretation, the middle height value of the sample is 70 inches. Mode is a little bit tricky because, well, not tricky, but there's kind of two ways to look at it, I think. The way you probably learned it as a kid was it's the most frequently occurring value. But in stats, we kind of want the peak of the distribution. So like if I were to fit a nice smooth curve over my data set, the mode is the local maximum of that distribution, okay? Which is kind of synonymous with the most frequently occurring. But you could have a data set with a lot of data points. This is numerical now, right? And you might want this value right here, kind of, right? But you might have a value of 7.45, 7.46, 7.47, and none of them are exactly the same. And you could just by random chance get two values here that are 7.01 and 7.01, and no other ones match, and then that would be your mode by this definition. So that's not really what we want. We want the peak, or the general area where we have the most data points. So let's just think of mode as the peak of a numerical distribution and not worry about how to calculate it from the numbers, Interpretation, the most frequent height value from the sample was 65 inches, I'm sorry. Measures of spread. So this is where things are going to start to maybe get a little bit new here, right? Range is simply defined to be the maximum value minus the minimum value. So this is a single number. That's the only thing you got to be careful about. I know people want to say, well, the values range from 60 to 100. Well, that's not the range. That's why I say the data values span from 60 to 100. Obviously, there's more than one definition of range. There's multiple definitions of words, right? But in statistics, range is a single number, which in this case would be 40 inches or 40 whatever, right? So always report the range as a single number and don't talk about it being an interval of numbers, okay? It's actually the width of the interval of those numbers. The heights of the sample of JCS students span an interval of 22 inches. This is how you could interpret it. IQR, interquartile range. This is defined to be the third quartile minus the first quartile. Terrible way to define things when I haven't defined what these things are. But if you have a data set here, the median is that middle number, right? Well, if you separate the data set the median separates the data set into two chunks. If you take the median of the lower data set, that's going to be quartile 1, And if you take the median of the upper data set, that's going to be quartile 3. So the quartiles kind of divide your number line, your data set into 1, 2, 3, 4 chunks, each representing about 25% of your data, right? Which is why we call them quartiles or quarters. In fact, sometimes the median is actually called quartile 2. Yeah, so once you find those quartiles, then you can just take the interquartile range, which is just Q3 minus Q1. Let's just look at a couple of examples here just to show you what it's going to look like. If we got data, if we have odd data, 1, 2, 3, 4, 5, 6, 7. That's our data set. Then to find the median, we're going to go to the middle. Boom, boom, boom. So the median, the middle number is this number. That divides your data set into a 3 on the bottom and 3 up top. Most software programs are going to omit that middle data point whenever they break it into the top and the bottom. Then we find the median of our bottom. That's going to be Q3, or of the top, and the median of the bottom, which is Q1. So the IQR would be 6 minus 2, or 4. It is a measure of the interval length that captures the middle half of your data set. That's what IQR is. Let's say we got 8 data points. It's a little bit easier now because we had even data points, so we go boom, 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 boom. Our middle number, the median is going to be right in there, right in between those two, so that would be 4.5. That would be our quartile 2, or our median. And that separates the data set into 2 chunks, so the median of the bottom half would be 2.5, that would be Q1, and the median of the top half would be 6.5, which is Q3. And then the IQR would be 6.5 minus 2.5, which is 4. And again, it is a measure of the width of the interval that captures the middle half of your data set. That's IQR. To interpret it, I guess we'll put a star by this interpretation because this gives kids problems. The middle 50% of the heights of the sample of JCS students spans an interval of 6 inches. Standard deviation, that one gets 3 stars because this is a really, really common interpretation. You got to know this one. So standard deviation is kind of the most popular, common, widely used measure of spread. I mean, there's nothing wrong with interquartile range. There are some things wrong with the range, but anyway, we'll talk about that later. Sample standard deviation is defined to be S, and the population standard deviation is defined to be, sigma, or sigma sub X, or sigma sub Y, depending on whatever you call your data set. Here we're calling it X. So notice these formulas are different. First of all, they probably look a little complicated, but they're not too bad really. But here, so basically what we're taking is we're taking each of our X values and subtracting it from the mean. Then we're squaring those values. Then we're adding them up. Then we're dividing by n minus 1. Then we're taking the square root of them. Over here, same type of thing, only we divide by n instead of n minus 1. So you might wonder, why are these different? That's a difficult question to answer. It's kind of BAPS. It's kind of beyond our class a little bit. I am going to attempt to explain it here in a little bit, though, okay? Because I do think it's important for you to understand why they are different. To interpret it, again, star this. You got to do this. In this sample, JCS student heights were or are typically 4.2 inches from the mean height of 66.9. It's the typical distance from the mean. Standard deviation is the typical or average distance from the mean. That seemed to make sense. You know, how spread out is your data? Well, our data points are on average 4.2 inches from the mean. Oh, that kind of tells you that some are going to be 4.2 inches above, some are going to be 4.2 inches below, some are going to be 2 inches above, or 2 inches below, or 1 inch above, or none, or some are going to be maybe 8 inches above and 8 inches below. But on average, that distance from the mean is going to be about 4.2. Variance is linked to the standard deviation directly. The variance is simply the standard deviation squared. So basically, and we don't even give it special notation. We just call it S squared and sigma squared. And it's the same formulas. You just take away the radical. That's it. So if the standard deviation is 4 inches, then the variance S squared is going to be 16 inches squared. So the units of variance are in units squared. So we don't really interpret the variances like we do the standard deviation. That's kind of why we prefer the standard deviation. But there are some very specific reasons why statisticians like the variance. It's going to have some very important properties down the road. So, okay. So find the mean, median, range, IQR, and standard deviation by hand, and then find it with the calculator. All right, so I like the videos to be about 15 minutes, but this one's going to have to be 2 because I don't want to start this and not be able to finish it. So see you next video.